Okay, what's up everybody? Today I'll be going over the problems. There's some sketchy ads, so don't worry about it. But the idea is like this. Let me just make sure my thing's working. So you're given four different, you're a programmer who just took a test and you're in four different groups based on the score you got. So 0 through 39, you're a novice, 40 through 69, you're intermediate, 70 through 89, you're advanced, and 90 through 100, you're an expert. One thing you'll notice is that instead of 40 right here, I put 39, and that's because it says less than 40. That means 40 is not within the novice area. So it's within this range. And the biggest problem was that people sometimes were considering 40 within some of their ranges, or 70 in intermediate, or 80 or 90 in advanced. And that was the biggest problem. Loaded. So that was the biggest problem. In order to solve, so your question is, if you're in novice, right? Okay. If you're a novice, let's say you have 20. How many points do you need to get to the next level, which is intermediate? In this case, the lowest amount is 40. So 40 minus 20, you'll need 20 more points. And the idea is you take the lowest value needed for the next level, which is 0, 40, 70, or 90, these four numbers, and you subtract it with your value you have. Okay. So that's kind of the solution, actually. That's really it. If you look at my code, time limit. Lol, imagine being slow. That was D. This is C++. Okay. What I did was I used scanner, so remember I have to use imports. And then I took in an integer, next int, and then if it was less than 40, I just subtract 40 from it. If it's less than 70, I subtract 70, less than 90, subtract 90, and then else, I just print out expert. Because expert doesn't have a higher level, so it's expert. A lot of people put a lot of extra stuff in their statements, and that's okay, as long as it's correct. The thing is that just leaves more room for error. But yeah. So, but basically I did just the lowest number that was closest to it, which would be 90 or 70, and I subtracted by its current value. That's kind of it for A. For D, it was pretty interesting. It's actually a very simple solution. And you're given, so you have a bunch of friends going to your party. Let me just, nope, not that, definitely not that. So you have a bunch of friends going to your party, and you can, yeah. So I can either cook 6, so I'll say pizza, and this will be the time. Actually, it was 15. So it took 15 minutes to cook 6 slices of pizza, 20 minutes to cook 8 slices of pizza, and 25 minutes for 10 slices. And so you have a bunch of friends coming over, and you're trying to find the minimum amount of time to get 1 slice for each friend. So if I had I don't know, 12 people coming over, right? What I can do is I can make 2 batches of 6, and each take 15 minutes, so I can just say 15 plus 15 minutes. And the total would take 30 minutes. And that's the optimal time, the minimum amount of time needed to cook all the pizza. If you had 14, right? Yeah, you can use a set of 8, so it would be 20 plus 15, because kind of like that. If you had 15, however, there's no even way to divide it optimally. So what you'll have to do is you'll have to round up, or actually what you'll do is you'll make 2 batches of 8, which is 20 plus 20. That's 40. Even though you have 16 slices, because each is 8, it is enough to fill or have everyone to have a single slice of pizza. Now, an unoptimal way, or like a way that's not efficient, is through 6s. If I made 3 batches of 6, it totals up to 18 slices, but it takes 45 minutes rather than 40, and that's not optimal. Okay. So in order to make the optimal amount of time, like the minimum amount of time, actually, we'll start with an observation. So with a lot of problems, you have to notice like key concepts or key pieces of information. And if you simplify every single one of these as like fractions, you will get 5/2. Notice how I'm putting the time on top, because time is what the minimum time is what is asked for. What am I doing on? Yeah. The minimum number of minutes is what I'm looking for. So the cool thing is, if I do this, it would be minutes over pizza slices, right? And if I'm given the amount of people, like 12 people, each person needs a pizza slice, I can cancel out P, and I end with the amount of time, which is kind of cool. If you've ever taken like chemistry in sophomore year or physics, it's kind of cool. It's like you'll see the units cancel out, but that doesn't matter. But yeah, so the idea is that since every single one of these ratios is equal to each other, that means we could simply just use this ratio to find the optimal amount, if that makes sense. So what I did in my solution was I did this. So first things first, I divided by 2, and then I multiplied by 5, just like this ratio. Now, one thing you'll notice is that I added x by 1, and that's because I want to, it's kind of a code computer science way to round up. So if I had 5, if x equals to 5, I would add 5 by 1, and it would be 6, and I would divide by 2, and it's 3. Okay. If I have 4, I add it by 1, I would have 5 divided by 2, and since it's integer division, I round down, so it's not 2.5, but it's actually 2. Okay. So the thing is, by adding that plus 1, it makes it so that I round up, if that makes sense. If I wanted to round up from divided by 3, I would just say x plus 3. You'll see this pattern come over and over again. It's kind of hard to explain, but this is just ceiling division, so it's rounding up. This is just a good way to round up. But yeah, and so also in this problem, you have to use test cases, and test cases just give you the number of numbers that follow. So 6 would be t right here. You can see the input, single integer t, the number of test cases, and then after that, it follows 6 different numbers, and you have to solve for 6 different problems. So yeah. But that's it. That's A and D, which is nothing much. B and C were just too complicated. If you want to look at my solutions, I'll give you a quick peek. You can pause the video. I'm glad people were trying to solve B, but B is really hard, and I highly suggest y'all should try that. But this is my solution in C++. I use pair, which we discussed in class today. Map, you guys don't know. This is a vector, which is similar to ArrayList in Java. But yeah. And then C. Arguably, this actually uses what's called dynamic programming, which is hilarious because it's one of the hardest things in computer science. It's not necessarily advanced, but it's kind of what it does. Let's take a look at it. And then, yeah. That's A and D, and then a quick peek at B and C, or B and C. But I hope you all enjoyed. My computer kind of sucks, so my FPS must be really low. But have a great day.